Hey boys and girls, for our math warm-up today, I have four multiplication problems with decimals here for you. And what I would like for you to do is number your paper from 1 to 4 or your board and make an estimate for each one of those so that you can determine where the decimal point should be placed in each problem. So go ahead and pause your video and complete those four problems. For the first problem, what I did was I took 4 7/10, rounded it to 5, 12 7/10, just made it 12, so 5 times 12 equals 60, which told me where I needed to put my decimal point was going to be between the 9 and the 6 for this first one. For the second problem, I took 107 5/10 and I just rounded it to 100 to make it really easy. And the 4 3/10 I changed to 4, which gave me 400. So that meant that I was going to put my decimal point between the 2 and the 2. And for the third problem, I took 15 8/10, changed it to 15, 19 5/10, changed it to 20. 15 times 20 is 300. So I placed the decimal point between the 8 and the 1. And for our last one, I took 112 5/10, changed it to 100, 66, I changed to 70, 100 times 70 equals 7,000. Came back over here, looked at my digits, decimal point goes between the 5 and the 0. So there you have it. For your math message today, you will need your student math journal, and you're going to open up to page 279. At the top of the page, for number 1, we're going to find the area of the rectangle in problem 1A, which is this one right here. Then we're going to talk with a partner about how we could find the area of the triangle in 1B and share your thinking. So here would be 1B. You may or may not have a partner to use with this particular math message, which is okay. I will discuss when I come back. So go ahead, pause your video, see if you can figure those out. So if we take a look at 1A, this is very similar to area problems that you've solved in the past. The problem was placed on grid paper, so there's a couple of different methods that you could have used. You could have gone through and counted the squares like I'm showing here, and then taken your halves and put those together to make a whole, which gives you an area of 21 units squared. Or you could have taken the formula for area, length times width, multiplied 3 1/2 times 6, and you should have gotten the same answer. Now, when we take a look at 1B, our strategy might be a bit different. So we know a lot about finding areas of rectangles. Imagine how we're going to find the area of this triangle. We don't have a formula for that yet, or do we? Can we take something that we know that may help us find something that we don't know? So what we're going to do with this particular triangle is I want you to imagine moving the triangle on top of a rectangle or making it into a rectangle. So what would happen if we put a dotted line here, or maybe just draw a line? I'm trying to get that as straight as I can. I don't have a ruler on here. And we made a rectangle. So if we were to find the area of the rectangle, notice that this is half of the other side. So could we use our formula that we know, which is length times width, and then divide it in 2 to get the area of that triangle? So I want you to pause your video and see if you might be able to figure out how to do that now that I gave you that very big hint. Did you figure it out? Let's take a look. So notice what I did was I looked at what is my length of this. If it were a rectangle, it would be 6 units. My width would be 3 1/2 units. I took the formula that this is the part that we know, And we're going to plug that in. So we've got 6 times 3 1/2. And remember, because we added this triangle here on this other part to make it a rectangle, we're going to divide it in half, because really we're only trying to find the area of this part right here. So we're dividing that by 2. So 21 divided by 2 is going to be 10.5 units squared. So our lesson today is applying the rectangle method for area, and it is focusing on area of non-rectangular shapes. The reason we're doing this lesson today is the world is not one big rectangle, is it? So we need to learn how to find area of different shapes. And how we're going to go about that is we are going to use our knowledge of how to find an area of rectangles and adapt it to find the area of shapes that are non-rectangular. So one of the references that will come in handy for you with this lesson today is your handy dandy student reference book, or your SRB. And if you open that up to pages 228 to 229, they're going to show you the rectangle method for finding area. So they pretty much explain how sometimes you don't have a rectangle and you have to use what you know about rectangles to find areas of triangles. So they're giving you several examples here. So here's an example like we did in our math message today, where we have a triangle and then they put a dotted line here to show a rectangle. You would find the area of that rectangle and then divide it in half to get the area of that triangle. Now, what is the area of the trapezoid? So notice, once again, that we have a shape that is not a rectangle. But notice, if I draw a rectangle here and make it, or draw a triangle, sorry, in that spot that's missing, it will form a rectangle. So step 1 is going to be able to draw the rectangle around the trapezoid. So notice the dotted line here. And then find the area of that very large rectangle, which is going to be 24 square units in this particular example. Then you're going to find the area of a smaller rectangle that would be the other half of that triangle. Hopefully you see where we're getting at here. So the area of the smaller rectangle is 8 square units. So A equals 4 times 2, which is 8, of course. The shaded triangle has the half the area of the smaller rectangle. Half of 8 square units is 4 square units. So that means that this part of the triangle that is not blue is 4 square units. So subtract the area of the extra large triangle that we found at the very beginning. So that would have been this whole rectangle here. So you're going to do 24 minus 4, which gives you the area of the trapezoid, voila, which is 20 square units. Pretty nifty. So basically we're taking a formula that we should be very familiar with. We're using it to make rectangles and form smaller rectangles so that we can find area of non-rectangular shapes. Okay, so to practice these strategies, I have a couple of shapes here. The first one, of course, is a triangle. And basically what we're going to do is we're going to turn it into a rectangle. And we're going to find the area. So we're going to use area equals length times width because we have a rectangle there. Our length is 1, 2, 3, 4, 5. So we're going to plug that in. And our width is 2 1/2. My stylus is not wanting to write correctly there. All right, so basically we have 5 times 2 1/2, which is going to equal 5 times 2 is 10, and 5 times 1/2 is 5 halves. and 5/2 turns into 12 and 1/2. And let's just check our math there. I'm having some major issues with my stylus here. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1/2. Checks out. So our triangle here, we're going to divide that in half, right? Because what we did was we found the area of the whole rectangle. So now we're going to take the 12 and 1/2 divided by 2. So half of 12 is 6, and half of 1/2 is 1/4. So that would be units squared. And there you have that first shape. So now let's take a look at our trapezoid that we have here on the right. And basically we're going to extend that line up and make this one large rectangle. We're going to use that same formula. So length times width. So my length is going to be 1, 2, 3.5. And my width is 1, 2, 3.5. Looks like 3.5 by 3.5. So we are going to multiply that out. Okay, so let's take a look at what we have so far. So I took the 3 and 1/2 times the 3 and 1/2. I got 12 and 1/4, which would be the area of this very large rectangle. Now remember, since this is a trapezoid, we're going to draw a smaller rectangle here that would show the other half of this triangle, which is on this side. So we're going to find the area of this rectangle now, and our measurements would be 1 and 1/2 times 3 and 1/2, which is going to give us 5 and 1/4. And remember that 5 and 1/4, we're now going to divide by 2 because we're finding half, right, of that rectangle, which would equal our triangle. So that equals 2 and 5/8. And now we're going to take that 2 and 5/8 and we're going to subtract it from the 12 and 1/4 to get the area of our whole trapezoid. So 12 and 1/4 minus 2 and 5/8. We don't have the same denominator, so don't forget we're going to have to do some converting there with your denominator. With the 1/4 will have to be changed to 8ths. But once you do all of that, your final answer will be 9 and 5/8 centimeters squared if we chose to use centimeters. So let's summarize this lesson for today. We are using the rectangle method to find area. Means that we take something we know to find something unknown by drawing rectangles around figures or parts of a figure. So let's knock them dead, guys.